We are now recording this, so if anybody doesn't want to have their cameras shown, feel free to turn your cameras off. And we also have you muted. So if you have any questions that you'd like to add, there's a Q&A box at the bottom of the screen. Feel free to type your questions in there and we'll get to them at the end of the session. If for some reason we are unable to get to your questions, we'll try and find some answers for you and we'll send them back to you via email, aim to do that by the end of the week. I just want to say a big hello to our researchers, Dr. Chris Roche and Professor Jeffrey Toffler. And you may remember Chris Russell, who's one of our wonderful ambassadors who hosted our Tea with the Experts webinar last time. And he's very kindly come back again to interview our lovely researchers. So we're so grateful to all three of you who have given up your time. I know how incredibly busy you are. So thank you so much for coming along and joining us for tea. I hope everybody's got their cup of tea. I've got my my Christmas themed mug. I've gone a little bit crazy with the Christmas gear because I do love Christmas. Anyone who gets my emails would know how much I love Christmas. I've got my earrings and I stole a headband from my 6-year-old daughter. So she's at school, so she won't mind. So I'm going to hand over now to Nikki, who is our CEO and who wanted to say a few words.
Great. Well, thank you, Jenny, and welcome to Heart Research Australia's Christmas webinar. But sadly, yesterday, 1.61 million deaths were recorded for COVID worldwide, which is really terrible. But to just put that into perspective, in 2019, 9 million people died of heart disease in just 1 year. So that's 5 times the number for COVID. And whilst there's absolutely no doubt we need to continue to tackle COVID-19 to stop it from getting even more out of control, we mustn't lose sight of the fact that heart disease has such a huge ongoing impact on our community and on our loved ones, which is why we're all here today. And so at Heart Research Australia, we are absolutely passionate about reducing that death toll and also reducing the impact on people's daily quality of life. So not surprisingly, during the year that we've just had, some of the research projects were put on hold, but because researchers were simply unable to access their labs for a period of time. But things have opened up again and research is continuing. But fortunately, during that time, researchers were able to write up their work and a number of researchers have published important articles, so that time wasn't lost. And now things are much more under control in Australia. We are looking forward to continuing the research with renewed energy. So thank you for continuing to support Heart Research Australia throughout this difficult year. Your donations have never been so crucial. So thank you for sticking with us despite everything that's been going on for you this year. So I'll now pass you on to our ambassador and MC, Chris Russell, who I have to say is fantastic at asking the right questions to make the research much more understandable. Over to you, Chris.
Well, we'll see about that shortly, Nikki, but welcome to everybody and thank you to Heart Research Australia for putting this on, which I always learn a lot and I hope you all do too. I'm not sure if there's such a thing of a conflict of interest when you're interviewing somebody because, you know, we're just a picture frame, but I have to declare up front that our first interviewee this morning, Jeff Toffler, was part of the team that I guess saved my life in 2004 when I fell into some very cold water. The other part of that team is Heart Research Australia that actually had set up these ATAMI systems in ambulances, which meant that I could get to the hospital really quickly and have that stent put in. So he and I have got to know each other pretty well as he's kept me under control, which my wife would say is an impossible task over all these years since. And it's a very great pleasure, Jeff, to welcome you this morning and have a chat about exactly that, you know, acute causes of heart attack, which has been your speciality for some time, I think.
That's right, and welcome, and thanks very much, Chris, and everybody.
Jeff, you know, we often hear and have heard in, you know, fairy tales for years of people dying of a broken heart. Is that just a simplistic sort of way of saying they were very sad and they didn't want to live, or is that a fair income reason that someone can suddenly have or trigger a heart attack, a bit like, you know, in the Indigenous population, the old pointing the bone thing, that they really almost kill themselves, or is that something that's got a medical or mechanical reason to it?
Sure, and it's interesting, Chris, and people on the webinar. A couple of years ago, I was on a panel answering this question, and also on the panel was a poet and a lawyer. So there was sort of other interested parties in this area. And I think there's very good evidence that there is a relationship between the emotional stress of bereavement in particular and an increased risk of a heart attack. And different scenarios are called broken heart. But if you think about the emotional links, there's bereavement, there's anxiety, there's anger, there's depression. All of these can be associated with an increased risk of heart attack. And it can happen in terms of changes that occur in the brain, the hormones that are released in association with these feelings. And these hormones can also result in what we call physiologic changes, increases in heart rate, blood pressure, clotting factors, spasm of arteries, all of which put extra stress on the heart and the arteries and can lead to a heart attack. And there are probably three sorts of heart attacks we can think about related to emotional stress. The typical one, or broken heart, the typical one is when there's what we call an acute coronary, where there is a injury to the plaques in the artery and then a blood clot that blocks the artery, and that leads to damage to the heart muscle. That's a heart attack. There's a second one that many of you have heard about more recently called Takotsubo, or stress-induced cardiomyopathy. It's a Japanese word reflecting the change in the shape of the heart, but what happens there is it's felt to be that adrenaline levels that particularly happen with an acute emotional stress, which can be with bereavement, can acutely damage the heart muscle wall without actually causing a blockage of an artery. And that's called Takotsubo. And then that typically is in postmenopausal women, but can occur in other people as well. And the third, which actually tends to happen in younger women, has the acronym SCAD, or spontaneous coronary artery dissection, again related to an acute emotional stress, which could be bereavement in younger people, and that can lead to damage to the arteries and a heart attack.
So what have we done with all this information? I mean, you can't do anything about people being absolutely heartbroken when a loved one dies, their partner or their parent dies. So you can't do anything about that occurring, nor can everyone be hard-nosed, commandos who just take it in their stride and move on. So what has your research shown about the way that we can actually ameliorate this when we know someone's just had a stressful event?
Sure. Well, look, when I was in Boston at Harvard, we had a large epidemiologic study, and we found that the risk of a heart attack was peaking in the first 24 hours. It was like 20-fold over the baseline risk. And then it was still 4-fold increase for the first month. And other people have found that the increased risk is up to 6 months after bereavement. So firstly, establish that indeed it is present. The second is that we looked here in research supported by Heart Research Australia at what are the changes that can occur. And as I mentioned, increases in anxiety and depression, increases in heart rate and blood pressure, and other clotting factors. And then the next step, which I think is very important, which is to translate it into ways that we can help people, is we did a trial where we used common medications, beta blocker and aspirin. In fact, it was published earlier this year with quite a bit of national and international publicity, that we could help some of these factors by this medication, which we gave in low dose for 6 weeks. So there's that potential. We need to find out who are the best people for that. In addition, things that other people can do, try to be as fit as possible at all times, because some of these emotional stresses are unpredictable. So keep your blood pressure, cholesterol under control. I'd recommend that bereaved people actually see their doctor to check on their state. I think family and social support is also very beneficial. And lastly, if people do start to experience some symptoms that could be related to the heart, don't ignore them, but seek help.
My daughter-in-law is a now quite an experienced catheterization nurse at Nepean Hospital, and I think she finds it very hard. There's only 11 of them, and they nearly always require her to be on call over Christmas because of the number of events and heart attacks that they have. So she's just as likely to be sitting down with us at the table. She's not allowed to drink, and suddenly she's got to be at the hospital in 15 minutes to save someone's life. Why is Christmas specially associated with heart attacks? Because typically when she's on call, she won't get called out in that period of time.
Yep. Well, we like to come up with an anecdote of a person we've seen. I like to sort of avoid anything identifying. You've identified yourself, Chris, in terms of what you've had. But there was one interesting one where Winston Churchill had a heart attack over Christmas when he was visiting the White House in 1941. So fortunately he recovered from that, but that's one anecdote. Look, there are a few things that could be contributors which we all could think about. One is the overeating that happens. The other is the emotional stress that can happen when family members are put together. I will say there was one heart attack that occurred when I was on call. I'm often on call as well, where a husband had made the mistake of being caught in the middle of an argument between his wife and his sister, and he was the one that ended up with the heart attack. So the emotional stress that could result, I think, potentially the excess alcohol that people often drink could be a contributor. And also unaccustomed exertion. I suppose if a child or grandchild gets a football and someone sort of rushes out to start playing, which they haven't done for a while. So there are a few potential factors. Maybe here in the northern hemisphere, it's cold weather, so that can be a factor. Here, excess heat could also be a factor as well. So there are a few factors that could contribute. And there was a Swedish study published a couple of years ago that showed a 20% increase in heart attacks at this Christmas period time over normal.
I think a few of us might have been stressed about the White House recently. We haven't even been there. So I can relate to that part of it. But in terms of the food, is it purely the amount of food, or are some foods, you said alcohol is an issue, but yeah, are there any foods that we should avoid at Christmas if we don't want to end up on your catheterization table?
Sure. Look, we've done a study here at North Shore where we have collected a lot of data on 700 people with heart attacks confirmed with angiography. And one of my junior colleagues, Lorcan Ruan, has presented his data showing a 4-fold increase in risk of a heart attack after eating what the person regarded as a heavy meal or a fatty meal. So they're factors that we found in ours, and it can be because it increases the clotting in the tendency in the blood. It's not just fatty meals, high sugar loads as well in the context of a heavy meal can increase pulse rate and blood pressure. So fatty meals are the ones that have been particularly studied, but I would say heavy meal in general could be a factor.
So that's no White House, no fat, no alcohol, and no sugar. I'm not sure whether your research is heading for success or not here, Jeff.
I just add that as all of our grandmothers said, moderation in everything. So
moderation in all things, exactly right. Another mystery to me, which has always been, it seems to be wrong in nature, if you like, is the way you see very fit people who, I had my co-host on New Zealand radio, his best mate, who is our age, but runs the marathon every year. He was actually training for the marathon. He runs every day, probably runs 100 kilometres a week. And yet in the middle of a run, he suddenly collapses and instant death. It just doesn't seem right. Now, I think part of his problem was that he thought he was still immortal because he was so fit. But, why do people who are so fit and they do eat well and they do all the things you tell them still die all of a sudden?
Yeah, well, look, Chris, I think it is an important point, and I think the reality is that there are lots of risk factors for people in terms of heart disease. Genetics is a factor. I think that we recently completed a study in football players. These were fit individuals, and when we asked them about what symptoms they may have had, 1/4 of these people had reported symptoms that were suggestive of heart disease in the prior 6 months. So I think that one important thing is that maybe some of these individuals are getting some warning symptoms that they are ignoring and sort of pushing forward. But a lot of work needs to be done in these heavy marathon athletes. There is indeed some data suggesting that there could be increased calcification that can occur in some of the arteries. So it's not a clear-cut factor. In people, 35 is a bit of a cut-off period in terms of risk of sudden death, particularly during exertion. In people under 35, it may be congenital conditions that increase the risk. Usually in people over 35, it's related to coronary artery disease, and so people keeping their risk factors as good as possible is important.
So where to from here with your research, Jeff? I mean, your speciality has been investigating these acute causes so we all know what to avoid. What's your passionate project now that you've got ahead of you?
Yeah, well, look, thanks, Chris. And again, at the outset, I wanted to acknowledge the help of Heart Research Australia to get me to this level. My particular interest at the moment is to do a study that builds on these triggers to say, well, what can we do to prevent the heart attacks associated with them? Because traditional risk factors don't fully explain people's risk. And so we've developed a program called Triggered Acute Risk Prevention, where we look at medications such as aspirin and low-dose beta blocker, and look at the particular triggers. So we haven't talked about it, but respiratory infection is an important one. Days of pollution is also a factor, and then see what we can do to intersect these risk factors and acute risk factors and lower people's risk. So that's an important area. The second study that we're involved in is also tied in with prevention, and that's again feeding on the fact that with COVID, a lot more things are happening with telehealth, and we have a very interesting protocol to help smokers stop smoking, and that's something that we're looking at ramping up to help there. And recent preliminary data has been very exciting that 60% of our smokers have stopped smoking. So they're two of the big studies that I'm involved in.
Wow, okay. I mean, it's amazing that we're still battling with smoking. It's so addictive. Just a final quick question, yes or no answer really. You know, if we put aspirin in the water like we do fluoride, I'm not suggesting any government would ever do that, but if we did, what rate would that reduce heart attacks by?
Yeah, look, it's a fascinating question. And in fact, one of the co-investigators who's going to be working with me on this trigger study, John McNeil from Monash, he'd actually done a very large study of daily aspirin. And in fact, he found that in their particular population, these are ones without known heart disease, that daily aspirin, in fact, was associated with a bit more bleeding, and that offset the benefits associated with reduction in heart attacks. So what we're talking about is not just on a daily basis for our population, but particularly at times of increased risk.
Right. Okay, well, look, that's great. I'm going to introduce our second guest today, Chris Roche. And I might start by asking both of you this question, which I must say has intrigued me really through this whole COVID year. Now, because, you know, in terms of COVID, we've been working for 50 years on finding a cure for another coronavirus called the common cold. Never succeeded. In 8 months, we've got a vaccine and maybe cures as well for a coronavirus COVID-19. We looks like we're going to release it within a year. And yet, if you look, as Nikki alluded to originally, in 2018, there were 41,800 direct deaths from heart disease in Australia, and an associated cause of death for another 70,000 people. Now, even if we'd had the same death rate as they've had in the US, which we haven't, we've only had, well, I say only, we've had 908 people die, which is tragic. But if we'd been in the USA standard, we would have had 22,100 deaths. That's still half what we lose every year in heart disease. And yet a piece of transformational research like we're going to talk about with Chris, or with the work that you're doing, Jeff, you know, once we discover it, can take 10 years before anyone, you know, sees it on the table. What's the problem? Is it red tape? Is it money? Is it the drug companies trying to sell more interim drugs before they get the big one? You know, why does it take so long, and why has this been able to be so quick?
Yeah, thanks, Chris. That's an excellent question. I'm glad you warned me that you're going to ask me that question in advance, because I don't want to say anything against the achievements of people who invent vaccines. Because actually the story of vaccines is one of the most impressive things in modern medicine. You know, the vaccination research that goes on eradicates whole diseases from the earth. So, you know, it's kind of a credit where it's due type thing, and the response to COVID is brilliant. I don't know if there are attendees who do vaccine research, but I personally don't know too much about exactly how a vaccine is researched compared to what I do. But in answer to your question, yes, it certainly is a priority, cardiovascular disease, heart disease. And yes, certainly it's a complex thing, but there are financial implications, you know, to do with the financial backing of certain projects. And there's also things to do with how new the stuff that you're trying to do is. So what we're trying to do, which is to regenerate damaged heart muscle specifically, that's kind of lagging behind what other people have been able to do to replace a heart valve, for example. And that's really something which is due to how complicated it is to regenerate the heart muscle. So I don't want to go off on too long an answer, because the attendees might switch off if I start talking too much about myself or my research. But essentially, it's complicated. There are studies that have been pursuing this in huge labs, and they're making progress over the last 20 or 30 years. The most recent one happened in humans, actually, with 6 patients having a patch put on their heart, and that was really promising. But it does take time. It's a huge endeavor, and you know, when we do achieve it, it'll be a massive achievement as well.
But I wonder whether a lot of it is red tape. I mean, my dealings in agriculture with the regulatory body for that, I mean, they think in months like we think in weeks just to look at something. Is the red tape part of the problem? Jeff, have you got any comment about that?
Look, I think that red tape is certainly an issue, but I think it's more this idea of the sense of urgency to get something done. And you know, heart disease, you know, people die in all ages, from young to old, and yet there isn't that same sense of urgency. And you know, funding research has been described as similar to fuel for an aeroplane, that you put fuel in and then it can fly to you know, 30,000 feet. And I think that idea that we put money in and we get a huge return is something that is known, but I think it's probably without that sense of urgency. And I think it is important. We all have family members, friends, and we just need to keep that in mind, that there should be a sense of urgency. And perhaps we'll learn from what's possible with the vaccination program, how rapid it's been to try to extrapolate that to heart disease.
Yeah, maybe the cat's out of the bag now. Well, coming on, Chris, with your work, because I find this work that you're doing absolutely transformational. I remember talking to your supervisor, Carmine Gentile, some years ago at one of the heart research lunches. You know, this whole idea of being able to use a photocopier to make little patches, when the bio ink being full of stem cells that then grows. I mean, it almost like sounds like something out of, you know, a future science fiction novel, and yet this is what you're actually doing. I'm wondering about the fact of how long that's taken, given that in fact, generally stem cells, we seem to have found we're using it in bone marrow, but I'm not sure I'm aware of any other big area of medicine where stem cells have really come into their own. Is this going to be the next one?
So certainly we hope so. Perhaps just before I answer properly, if I just say to some of the attendees may not know exactly what my project is about. And what we're trying to do is we take a skin sample from any patient, we reverse that into a stem cell state, which is a cell that can turn into any of the cells in your body. And then we try to fast forward it into a heart cell type. And then we put that in certain patches. And the patches are made of something which is very much like a shower gel, but it becomes a bit more solid, a bit like a plastic at colder temperatures, and a bit more like a gel at warmer temperatures. And then the 3D printer is actually, it's kind of a simple concept in a way. You have a syringe with a plunger, and it moves in the X and the Y axis, so it can move forward, backwards.
A bit like an inkjet printer, really.
Yeah, and once it's done, it moves up and it does whatever you want it to do on the next layer, and then the next layer, and the next layer. So if you want to, you can make that look like the Sydney Opera House or whatever you program in on the computer. And then what we do is we put the stem cells, or actually whichever cells we want to test, into that bioink. The bioink, which is the gel stuff that's in the syringe, is very nourishing for cells. And that's where Carmine Gentile, my supervisor, came in. It's kind of his thing where he kind of figured out exactly the best way to do that in a way that the cells then thrive, because you can't just do it in any old way and then the cells just die. And then once we have these patches, we can actually have them in the laboratory for a little while to make sure they get a bit of blood vessel going on, to make sure the cells are doing okay before we actually transplant them.
So what sort of stem cells are they? Are these fetal stem cells, which have always been a little bit controversial, or are they adult stem cells you get from yourself?
So they are a special type of stem cell, which is called induced stem cells. So as everybody knows, there's a sort of ethical question about using embryonic stem cells, because you actually have to take those from an embryo. Which means that the embryo can't continue to develop. So you're creating an embryo, and at a very early stage, you're taking the cells. And then there are pros and cons with different types of stem cells, which probably I don't need to go into too much detail, because everyone will need another cup of tea if I do that. But it's essentially the induced ones are these taking another cell, like a skin cell, backwards into an induced stem cell, and then it can become anything you want. And it's kind of like a superpowered stem cell, because it actually doesn't get old in culture. Once you have them, you can have it in the lab or in the freezer for as long as you want. And that's quite useful too. And so those are the specific type of ones that we're working with. And they were invented.
These stem cells, why do they, when you put them in this little patch on your heart to rebuild your heart, why don't they wander off and try and rebuild a heart down in your liver or somewhere, which I imagine would be called cancer?
Yeah, so that's a really, really good question. If you just put stem cells in the heart, which people have tried to do in the past, there is a worry that they will develop not into the type of cell you want, but into a cancerous cell or something like that. In reality, that doesn't seem to happen too much so far, because the body has quite a few defense mechanisms against that, but it is a worry. And so we try to coax those stem cells forward into a heart cell state. So we call that differentiating. So it's already decided, right, I'm going to be a heart cell. And then we think that there's going to be less chance that it's going to decide from that to become a cancer cell.
So did you decide that as a researcher, or did the cell somehow work that out?
Yeah, so we coax the cell. So we give it a few hints what we want it to do. And actually, I'll be honest, that's quite difficult. So, the people who invented this, the so-called, I think it's Yamanaka, they got the Nobel Prize for inventing this technique.
It's only
about 10 years old. And it's gone through a few generations of improvement. But essentially where it's at now is you have to go into the laboratory every day for, 8 weeks or so. And you add certain things to the cells to tell the cells what you want them to do. And then after you've told them, you leave them to kind of do what you hope they're going to do, and you add new media and various other ingredients. It's a little bit like cooking a cake for 8 weeks.
So you've got your little inkjet printer has printed out a little patch, which has got all these gels and these cells all through it, and they've all been programmed to only make heart tissue. So you then lay it on top of the heart. First question is, how do you stick that on so it doesn't just fall off as soon as you go for a walk?
Yeah, so that's a really good question, because you could use special glue, but then of course you'd be putting glue between the patch and the heart, and then that would kind of defeat the point of trying to put that patch, because it probably would stop it making connections. So actually we found that this gel-like substance, it kind of adheres to the heart quite well. Now we thought we might have to put surgical sutures into it, which are stitches, because you can do that on the heart, but the heart is a very delicate tissue, and if you want to, or if you can, you don't want to really be putting too many sutures in there. So actually, we think at the moment, and this is something new that came out of our project, that you don't have to do any of that. It will just stick to the heart because of the natural adhesiveness of the gel in the patch. And then that's actually quite good, because the heart is beating, so you actually want a little bit of flexibility, a little bit of movement in the patch. And you know, it is something that we're looking into. So if we find in the future that actually all of our patches slip off, then we have to approach a different way. But at the moment, that seems like it could be one of the big findings from our project, which other researchers look at and say, oh, look, we don't have to put a stitch in the heart or glue, because it'll stick by itself. But, you know,
so
we'll see.
Is it then like a sort of lawn turf, that it grows roots into the heart and sort of binds itself in by the cells mixing and growing into the heart?
Yes, that's exactly it. That's a really well put analogy. It's like that. That's what we hope will happen, that it'll start to make connections.
And what about the blood supply? I mean, how does it exist? Because initially it's got no blood vessels in it. So does it need blood supply, or can it last for 6 months without blood, or how does that work?
So yeah, the blood supply is a hugely important part of this, and it's been the focus, it's like the major challenge of how to do this. It's been the focus of a lot of work. Essentially, the blood supply will naturally start to form with these very tiny micro connections. But as you can imagine, you actually need a hierarchical blood supply, because it's no good just having country lanes. You have to have highways, then you have to have slightly bigger roads and so on, right down to the really small ones to reach the house in the countryside. So that's a difficult thing. We think that if you get a little bit of vascularization going before you've even transplanted, so you kind of already, the turf is already making roots, and then you transplant, then that should very quickly start to make these micro connections, and then it should naturally, the body should build that hierarchical, some roads big, some roads small type thing. So that's our approach, and that's what we hope will happen.
Now, I noticed in some of your pictures that the little patch is sort of beating away by itself in the petri dish. So when you put it in the plant, does it in the heart, does it take the same beat as the heart, or does it doing its own thing on the side? How do you get them synced?
Yeah, so that's another huge part of this, which is that it is difficult to get it to synchronize with the heart. And that's especially true because if you put it on the heart over an area of heart attack, that area of heart attack is damaged or it will be dead cells. So it's actually a very difficult thing to get this patch in sync with the heart as a kind of whole. But if the edges of the patch reach the heart and the electrical signal, which goes down the heart like this, and then the electrical signal makes the cells contract like this, if that can pass through your patch, then we hope that it's a little bit like if you put a bit of wiring in an electrical circuit and you know, something is turning on, off, it should go through that wiring.
So how far are we? What's the most advanced? I mean, this all sounds like a whole bunch of, yes, that's really important. Yeah, we've got to do that and so on. There's so much stuff to sync here. How advanced are we, and what's the most advanced study that's been done globally on this so far?
So the most advanced study is the one that I mentioned earlier, which is a French study by someone called Menachet, and they took some patients that happened to have heart failure and were also having a bypass, and they were having just one bypass, and they put these big patches, they were quite basic patches made out of a clot-like material with some cells in it, not that many cells, and they basically put them on the heart. And that was just to show it was safe. So they only had 6 patients. But it did show that it was safe, and it even showed that it actually improved their heart failure, but that wasn't the purpose of the trial, so they couldn't really say that, but they said it looks quite promising. So that's the most advanced study. That was 2 years ago now. And then there are quite a lot of studies, large animal studies, for example, which are also really, really promising about this. So that's why there's a lot of energy behind this at the moment, and a lot of hope that it might have a breakthrough at some point in the near future.
So if the bureaucrats do learn their lesson and we're able to get this red tape sort of a little bit more sorted. You know, when do you think I'm able to go in and Jeff can put one of these on and my bottom right-hand side of my heart can get a bit of activity again?
So this is where I feel like I'm going to react like a British politician answering a question about Brexit. Because especially with this being recorded, it's the sort of thing I'll say, oh yeah, you know, give it 5 years, and then my face will be projected somewhere in 5 years and it won't be happening. Or, you know, I'll say, I'll give it 20 years and then it'll happen tomorrow. This big paper will come out and someone was working on it and they did it. So as researchers, I think we're always a little nervous to answer that question. But if you know, it's always a bit unsatisfactory. So, you know, if I put it out there as a kind of probability, I think it would be unlikely to happen in the next 5 years. I think it'd be extremely likely to happen in the next 70 years. And then the probabilities would kind of get, you know, a little bit closer around 20 years. To really roll it out and have it going properly as a kind of way to patch your heart if you've got a heart attack causing you heart failure, and then we can patch it, and then that means that you're good. So that's my answer.
I think what you're saying, Chris, is we need to get cracking, and I'm really, that's the whole point of this. As I've said before, I think the thing that's always frustrated me about Heart Research Australia is the fact that all you guys I learn about have to spend so much time arguing for money all the time instead of just getting on with what you're able to do. And so all I can say to everyone who's watching, you know, when you look at the amount of work to do, if the best thing we can do is tip some of our hard-earned in to accelerate it, we couldn't probably do any more than that. We don't have the minds, these guys do. So I would urge you to do it. I'm sure there's a lot of questions though, Jenny. Would you like to bring some questions in and ask us?
Yeah, sure. We've got one question from Don May, which is there any early research? This is, I think, for Jeff Toffler. Is there any early research with vaping and e-cigarettes being a significant concern for our youth?
Yeah, look, it's an important question with e-cigarettes, and I think that anything we can do to reduce the smoking in a safe way is important. Unfortunately, the jury's still out in terms of the safety of e-cigarettes, in terms of what the added components may be, and in terms of does it really stop people smoking. So I think the jury's still out. There could be a role in some individuals, but you know, we don't want the young people to pick up smoking and the habit which potentially could happen with e-cigarettes as well. So I'm still very much sort of in the line of let's do what we can to affect the behaviour change, but also try and stop people starting. But it's a good question, and I think we need to be open to all avenues, and that one's certainly being explored as well.
Another one from Stephen Allen. Is there any correlation or effects between a quadruple bypass and the brain?
Sorry, just ask that one again.
Is there any correlation or effects between a quadruple bypass and the brain?
I mean, I'm not sure if I know exactly if there is, but as I'm a cardiac surgeon and there are cardiologists like Jeff doing different procedures, I would say that a heart bypass is not going to send off anything that's going to shower into your brain or anything like that. But this is quite an interesting area. It's sort of, you know, what happens after the operation in terms of certain patients becoming a little bit confused or something, and then do they get quite back to baseline after that? And there's a lot to it, and I'm not sure if that's answering your question directly. But ultimately, the actual bypass, which is a vessel that passes blood around the blockage that you have, that actually itself shouldn't cause any problems with your brain.
Yeah, maybe I can, because my father had that question, because he had some massive operations. And it seems that the doctors were saying that this is more about if you have an unexplained event, like a low blood pressure event or some other anesthetic event in there, maybe can do things. In my father's case, he had a subsequent problem with Lewy bodies disease, which is like an Alzheimer's type thing. And it seemed to me that the length of operation and therefore more risk of there being some sort of blood pressure event which could affect the brain is more than the actual surgery itself. Would that be true?
So yeah, there are loads of components that will affect the brain. So for example, if you go on the bypass machine, which is the machine that we sometimes use when we're doing a bypass, and confusingly, they're both called bypasses. So we're doing these bypass grafts, these roads that are going to cross the blockage that you have, but we actually put you on a bypass machine, which means that we're freezing your heart, so it's not beating. And if we stop your heart beating, then we have to put your blood circulating through a machine to get oxygen and so on. Now, being on that machine, it does sometimes leave patients a bit confused. So we try to do that as efficiently and quickly as possible. But having said that, there are patients who have huge, long operations lasting whole days, 12-hour operation. They could be on that machine and then they, can be fine. And then there are other things that can happen as well. But perhaps the person who asked the question has something really specific in mind. I'm not sure.
No,
Go ahead, Jenny.
Yeah, no, that was great. Thank you. Just one last question. In terms of, so for you, Chris, with patches being put on a heart, so if someone has a hole in their heart, for instance, like a lot of babies are born with a hole in their heart, and there is currently a process where they put a patch on the heart. What's the difference? I guess, are you able to use your techniques in the future, hopefully, to be able to use beating cells to go straight into these holes in the heart? Or is there a way that the patches that are currently being used can be then used for people who have the damaged portions of their heart to have that replaced?
So I don't really know exactly about that, because when you get into these hole in the hearts congenital things that kids have, it's a super specialist area. And I don't want to say anything incorrect or out of turn. But essentially my patches are really designed specifically with an older person having a heart attack and then damaged tissue from the heart attack being in mind. Whether it spins off in the distant future and finds a use somewhere else is an open question, and that does happen in science. But compared to some of the treatments for filling holes in the heart with, say, a pericardial patch, which is made from the lining of the heart, they're really good. So it might not be that my particular plan ever finds a home for that subset of patients, but I don't know.
Yeah, I'd add that there are different uses for the different sorts of material, and here, if it's a hole in the heart, then the goal is to stop the abnormal blood flow going from one area to another. So it's a bit more to sort of stop the abnormal flow rather than necessarily to add extra beating cells. But again, a very good question. And Chris, I wonder if I could just say, one of the projects I'm involved in, which is called PADDLE, Patient-Directed Discharge Letter, is to give patients information that helps them fully understand what is happening to them in hospital and their condition. And I think that a webinar like this and others is really valuable in terms of trying to get each patient to really understand what happens to them, not just rely on their doctors. Self-knowledge is very important. I think the more we can do that, in my project is one, but also in terms of the Heart Research Australia website, just sort of information that patients can take and then take on the responsibility themselves in terms of optimising their health condition.
Can I just add, in finality, Jen, if that's the last question, that, this is a very, exclusive access to the brightest minds in Australia, in this area, and something that, we don't get a chance to do. And the other side of that equation is communication. And that is really what Heart Research Australia does best. Now, I'm aware that this Red Feb is coming up next February, still a little ways off. So can I just say to everyone who's watching, you've been very privileged to hear from Chris and Jeff today, right from the horse's mouth, what's going on. Tell your mates about it. Encourage them to go to the Heart Research Australia website, which they do a huge amount of work to keep up to date. Get them involved with Red Feb and spread the word about the work that's been done. This has been a simple explanation. You can give them, anyone, the guts of what's been going on. It takes money and it takes communication to make this work. And that's our job, I think, and let these guys get on with solving the science and the biology. And just from my point of view, I'd like to thank Chris and Jeff for being so understandable, so transparent, just giving us something that we can grip onto and get enthusiastic about, you know, in what is really a very complex world of cardiology and heart research. So well done, and well done to Heart Research Australia on behalf of all of us for putting this on and bringing that to us.
Thank you so much, Chris. And, you know, thank you so much, Chris and Jeff. Your work is so exciting. As Chris said, you've explained it so well. You know, I think one of the biggest challenges I've had working here is trying to interpret all the science that comes from you guys, because I definitely don't have any form of a science background. So your work is so interesting, and we are so passionate and excited about it. So thank you so much. I know how busy you are. So thank you so much for taking the time, and for Chris Russell as well for coming and having tea with us. It's been, I hope you've all got your cups of tea, but you know, we're so grateful to have you here. So thank you very much. And thank you so much, everybody who signed up and who participated in watching. I will be sending out the recording later today. So feel free to send that on to your friends if anybody, you know, had it, or any points in here that you thought other people might be interested in watching. So we hope to see you again for the next webinar we do next quarter. But in the meantime, please have a wonderful Christmas to everybody. We hope that this rain sort of stops and we all have some beautiful weather, and please stay healthy. Listen to Jeff's tips that he said, and small meals, and go for a gentle walk, and please stay healthy this Christmas period. And thank you so much for all your support, and we're really excited for all the great things we've got next year for you. So thanks so much, and Merry Christmas. Bye.
Thanks, everyone.
Bye.